Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. You are watching Math with Yasir Arfat. We have the second lecture, the most important question on the exercise 6.1 sequence and series. The topic is arithmetic progression. So this is the third question which we are going to discuss from exercise 6.1. So here, question number 9, how many numbers are there between 256 to 789 that are divisible by 7? So here the sequence is given, that is interval is given 256 to 789. How many numbers are there between 256 to 789 which are exactly divisible by 7? This is the question. So it means first we have to make its arithmetic sequence or the arithmetic progression here. So first we have to find out two initial numbers which are divisible by 7 and the last number which is divisible by 7. So here we have to see this one here, 256. 256, it is not divisible by 7 exactly. 256, 257, 258, 259, from 256 to 789 to 59, it is the first number which is divisible by 7 from this interval to this number. What will be the second number? So just we have to add 7 here. We will get the another number there. That is 266. So just we have to find out first two numbers and the last number from this interval, that is 256 to 789 here. So now 789, it is not perfectly divisible by 7. So then 788, no, 784, yes, 784, it is the last number which is divisible by, exactly divisible by 7 from this interval 256 to 789. So first here 256 to 789, this interval is given. Between this interval we have to find out all those numbers which are exactly divisible by 7. So first we have to find out the first two numbers and then the last number. So this becomes the AP. This is AP, arithmetic progression. We have discussed in lecture 1, same exercise 6.1. So here A, it is 259. D, the common difference, 266, 259, that is 7. And last term of the sequence, it is represented by Tn, that is 784, the last term. A, it is the first term of the sequence. D means the difference between two consecutive term here. D is, it is 7, and 784, it is the last number of the sequence represented by Tn. And we have to find out total number of terms, those numbers, total numbers which are divisible by 7 between 256 to 789. So we have to find out n here. So here we have a formula, Tn is equals to A plus n minus 1 into D. So what is here? What is D? Tn here? Tn, it is 784. What is A here? A, it is 259 plus n it is required. And D, what is D here? This is the 7. So 784, 259, we have to multiply the 7. So this 7 will multiply n, so that will be 7n minus 7 ones are 7. So this is 784 it is equals to 259 minus 7. So that will be 252. That will be 252. 259 minus 7, it will be 252 minus 7. So now we have to shift this one here, left hand side. So this is 784 minus 252, it is equals to 7n. So this is 784 minus 252, that is 532, it is equals to 7n. So this 532 divided by 7. So this is 776 divided by. So this is 76. That means there are 76 numbers. There are 76 numbers which are exactly divisible by 7 between 256 to 789. So always remember that when the interval is given, so first we have to make the sequence there. This is arithmetic sequence. So first we have to find out two initial number which are divisible by 7 and the last number which is divisible by 7. It becomes the arithmetic progression, and just we have to apply the formula. We have n is equals to 76. That means there are 76 numbers exactly divisible by 7 from 256 to 789. Okay, dear students, now come to the last question, the most important question of exercise 6.1. This is the second lecture. We have discussed total 4 questions of exercise 6.1 arithmetic progression. In lecture 1, we have discussed 2 questions and we have also discussed the basic of the arithmetic progression as well. In the second lecture, we have discussed 2 more questions, and this is the last question, which is the important question we are going to discuss with you students. So here, show that the sum of the p plus qth term and p minus qth terms of an AP is equal to the twice the pth term. So here, if before starting the question, here I would like to explain what is the meaning of p plus qth term. For example, if question says third term means T3. If question says fourth term, that means T4. If question says qth term, that means TQ. Pth term, it can be written in the form of TP. So now come to the question here. Show that the sum of p plus qth term and p minus qth term of an AP is equal to the twice the pth term. So here T p plus qth term means TP plus Q. Its sum. P minus qth term means T p minus q. That is equals to the twice of pth term, that means TP. So this is the equation according to this question here. Now dear students, again listen this point here. Show that the sum of the p plus qth term and p minus qth term of an AP is equal to the twice the pth term. P plus qth term means TP plus Q. P minus qth term means Tp minus q. According to the question, the sum of the p plus qth term and p minus qth term, it is the twice of the pth term. Pth term means Tp. So here first we have to find out the value of Tp plus q, Tp minus q, and then Tp. So we have a formula Tn is equals to a plus n minus 1 into d. So here first we have to find out the value of Tp plus q. Tp plus q means the value of n, it is p plus q. This is Tp plus q. So that means this is the value of n here. It is equals to a plus p q minus 1. So here this is the value of Tp plus q. Now Tp minus q, here it is equals to a, and what is the value of n here? N is p minus q. So this is p minus q minus 1 into d. This is minus 1. This is minus 1. A plus p minus q minus 1. What is the value of n here? The value of n is p minus q. The formula is n minus 1. So what is n here? P minus q minus 1. And we have to find out Tp. So Tp, that will be equals to a plus p minus 1 into d. So these are the some results which we have to use here. Tp, its value is a plus p minus 1 into d. Now we have to prove this equation here. This is the required result here. So just take out the left hand side of this result. That is T p plus q, p minus q. This is the left hand side. So what is the value of Tp plus q? It is a p plus q minus 1 into d. And P minus q, this is the value here, a p minus q minus 1 into d. So here just we have to put the value of P plus q, it is equals to this one, and p minus q, it is equal to this one, 8 plus p minus q minus 1 into d. So now we have to write down the like terms. P plus q minus 1 and p minus q minus 1 into d. So this is 2a, and take out d common here, p plus q minus 1, and this is plus p minus q minus 1. Just we have to take out the d common here. This d we have to take out common, and this one. So this is p plus q minus 1 and p minus q minus 1. So this q will cancel out this one. So this is 2a plus 1p plus 1p, it will be 2p minus 1 and minus 1, it is minus 2. So just take out 2 common here. So this is 2p minus 1 into d. And we have to take out the whole 2 common here. So this is a plus p minus 1 into d. So this is, if you have to focus here, this is a plus p minus 1 into d. It is equals to Tp. So that means it is Tp. left hand side equals to the right hand side. So dear students, we have two lectures on exercise 6.1 and we have discussed four most important questions of exercise 6.1. So please, first we have to see the lecture 1 and then you have to see the lecture 2. We have four questions which we have discussed here in these two lectures. If you like this video, please share it and subscribe my channel Math with Yasir Arfat. Allah Hafiz.